Assalamualaikum warahmatullahi wabarakatuh. My name is Genta Sentosa with ID student 123490009 from Instrumentation and Automation Engineering student. So in this video, I'm going to explain about proximity sensor and how they are applied in pneumatic system controlled by PLC. So this video is part of our pneumatic practicum, specifically module 6 on the 6th module, the use of proximity sensors in pneumatic system. So the objective of these experiments are: the first one is to understand the working principle of inductive and capacitive proximity sensors, and then to apply proximity sensor to control an actuator such as valve or piston using PLC, and then to apply proximity sensor to control an actuator to design a proper ladder diagram for automation control. And then next we will talk about the proximity sensor. Proximity sensor is a type of sensor that can detect the presence of an object without any physical contact. It is widely used in industrial automation to detect object position, count products, or act as a non-contact limit switch. The sensor works by emitting an electromagnetic or electrostatic field and detecting change when an object enters that field. So in proximity sensor, there are several types of proximity. In this module, we will focus on two types. The first one is the inductive proximity and the capacitive proximity. The first one is inductive proximity sensor. This type of sensor is used to detect metal objects only. The working principle is based on electromagnetic induction. Inside the sensor, there is an oscillator circuit that generates an alternating magnetic field at the sensing phase. When a metal object enters these magnetic fields, eddy currents are induced in the metal, which cause a change in the sensor's inductance. The sensor detects this change and outputs a signal, usually a digital on-off signal. In pneumatic system, the sensor can be used to detect the position of a metal piston rod in a cylinder. For example, when the piston reaches the end position, the inductive sensor sends a signal to the PLC to stop or reverse the cylinder movement. So that is for the inductive proximity sensor. Now we will continue to the capacitive proximity sensor. Unlike the inductive sensor, the capacitive sensor can detect both metal and non-metal objects, such as wood, plastic, glass, or even liquid. It works based on the change in capacitance between the sensor surface and the detected object. When an object with a different dielectric constant enters the sensing area, the capacitance changes. The internal circuit detects this change and generates an output signal. One common application is to detect material levels such as powder or liquid level inside a container. In pneumatic system, a capacitive sensor may be used to detect whether a product is present or not before the cylinder starts its motion. Now we will continue to the ladder diagram of the proximity sensor. So we will continue to make the PLC ladder diagram with CX programmer. So now we will open the CX programmer. We will click File, New, and then you can choose your device type. I will choose CP1L, and then we will click OK. And then we will start by adding the TB or switch. I will make 0.0 this is for the PB on, and and then for the PD off 0.01 for the 0.01, sorry, 0.01. This is for the PP off. Okay, then we will make for the out 0.00. This is system. Okay, now we will continue to the next layer. Don't forget to add here to 0.00 system. Okay. Now we will continue to the next layer. We will make system first. 0, this is system, and then we need the proximate 0.02 for the proximity. And then we add out for proximity. So 0.01 out proximity. Okay. Now continue to the next layer. We will make switch timer. This is for the switch timer. SW timer and system W0.00 system. Then for the out proximity, we will add out proximity 0.01 proximity and timer T0000 timer, and for the out timer 0.02 timer. Okay, don't forget to add timer also in the bottom, in here add here time, okay, 0 for the timer, yes, and instruction, we will add instruction timer in 0000 hashtag 50. This is timer. Okay, now we will continue to the next layer. We will add switch CNT, 0.04. This is for the switch CNT switch, and we will add system also, system and out proximity. Okay, see, and we will add instruction also here, CNT. This is for the CNT 0000 hashtag 1 CNT, and then add also here C0000 CNT, also add D0000 for the, sorry, D001 for the time CNT, and we will add also here C000 CNT. Wait, maybe oh sorry, I think there is a mistake here. I will delete this first. It should be here for the CNT C000 CNT, yes, here. Then P001 for the time CNT. Okay, this then we'll add here. This is for the C000 CNT. Then add instruction also here. In 000 000 wait, cancel hashtag 50. This is for the timer CNT. Okay, done. Then add here, 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 and the out is W0.03 for CNT. Okay, so this is for the diagram later. Now we will start to integrate the simulation. Okay, just like this. Because it is not connected to the PLC, so we cannot execute the diagram. Okay, so this is for the ladder diagram of the proximity sensor. Yeah. And then I think I will continue for the application of this proximity sensor in pneumatic system. So the proximity sensor acts as an input device to the PLC. The PLC processes the signal and controls output devices like solenoid valves that move the pneumatic cylinder. For example, when an inductive sensor detects that the piston has reached the end position, it sends a signal to the PLC, which then deactivates one valve and activates another to move the piston in the opposite direction. This creates an automatic reciprocating system that can move continuously without manual control, so it will move automatically. And this is the PLC diagram. uh, yeah, so in this rung or layer contains the proximity sensor input, and then include timer also, and then we can use set and reset instruction to make the motion sequence automatic. So for the result of this diagram, the pneumatic actuator can move accordingly. Okay. Uh, for the conclusion, proximity sensors are essential components in automation system. The inductive sensor detects metal objects using electromagnetic fields, while the capacitive sensor detects both metal and non-metal objects using electric fields. So the both sensor can be used to provide feedback to PLC and pneumatic system, ensuring safe and efficient control. By understanding the sensor principle and designing a proper ladder diagram, we can automate pneumatic operation effectively. So I hope you all understand. Yeah, like that. Maybe I will explain a little bit about this ladder diagram. Hmm. In the demonstration on trainer board, uh, we can see that we cannot see, but maybe we can, maybe you can try, or maybe uh, when we execute the program, the proximity sensor mount near the cylinder. When uh, when we move a metal object close to the inductive sensor, its indicator LED turns on. The signal is sent to the PLC input on the CX programmer monitor, so you can see that the input bit turned on as well. So, but we cannot connect to the PLC. The PLC activates the output coil that drives the solenoid valve, and the pneumatic cylinder expands. When we remove the metal object, the signal goes off and the cylinder retracts. So when we execute this diagram on the real PLC, it will show how the proximity sensor and PLC ladder logic work together to control pneumatic motion automatically. So I think that's a little bit explain about the PLC, and you can see here but we cannot connect because there is no port. We are not in the practical laboratory. So yeah, like that. mm, I think it's enough. I hope you guys understand about my explanation proximity sensor and how they are applied in pneumatic system controlled by PLC. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh. Thank you guys. See you in the next video, in the next module.